Welcome to the Packet on Volume. This is a mixed review of what you've learned on volume. You will need a formula sheet, so if you take a look at the very last page, which looks like this, you can very gently tear it off the back of your packet. You will see that here is the volume formula. You can see the last page, the formula page, looks like this. If you need to find the volume of a rectangular prism, you will use length times width times height. If it's a triangular prism, you'll use this formula. If you need to find the volume of a cylinder, of course, you'll use this formula. For a sphere, you can use this formula. And lastly, the volume of a cone, you can use this formula. And for those three formulas, when you use pi, you can use 3.14, the rounded version of pi. Now let's go back to page 1 and get started. Make sure you tear this back page off very gently. On page 1, please make a star under the line for your name. Problem number 1 says, calculate the volume for each. We have a sphere with a radius of 6 centimeters and a cone with a radius of 5 centimeters and a height of 10. If you go to your formula sheet and look at sphere, you will find the formula looks like this. Volume equals 4 times pi times r times r times r, all divided by 3. We only need a radius of 6 centimeters. Take a moment and substitute. 4, and remember, pi is going to be 3.14 times 6 times 6 times 6, and that entire quantity will be divided by 3. Grab your calculator and punch in the problem. When you come up with an answer, write it down, and you can even write it here on the line. Now for a cone, the formula is different. The formula for the cone is V equals pi times r times h, all divided by 3. Well, we know pi is 3.14, and the radius is 5 times 5 times a height of 10. And we're going to divide this entire quantity by 3. In a moment, you are going to pick up your calculator and multiply so we can get the volume of our cone. You can also write that final answer here on the line. Pause the video right now and use your calculator to find the volume of each. Do not turn the video back on until you've come up with the volume on your own, and we'll check it together. Pause your video now. For the sphere, you should have gotten 904.32. Give yourself a star if that's correct. For the cone, you should have gotten 261.66666 repeating. Rounded to the nearest hundredth, 261.67. Give yourself a star if that's correct. So which has the greater volume, the cone or the sphere? Clearly, it's the sphere. How much greater? Well, you're going to take the larger volume, showing your work, and subtract the rounded version of the smaller volume. This answer can be checked on the answer key when you're done. Go ahead and subtract, stop your video, and turn your video back on when you're ready to look at the pizza box below. Problem number 2 on the first page. Find the volume of the pizza box. Well, this is a rectangular prism. It has a length of 15, please place an L there, a width of 15 here along the back edge, and then, of course, the height is 2. As you look at your formula sheet, you can see we will be using the formula for a rectangular prism. Step 1, please write this down. Volume equals length times width times height. You're going to take a length of 15 times a width of 15 and multiply it by 2. Whatever you get, that is your volume in cubic inches. Pause your video right now and punch in 15 times 15 times 2 and write your final answer over here on the line as well. You can check this answer on the answer key at the very end. Please place a smiley face here and let's turn to the next page. I would like you to turn to the page starting with problem 3. Problem 3 states, find the volume of the mug. Use 3.14 for pi. We can see that the mug is in the shape of a cylinder. So if we go to our formula sheet and look up the formula for cylinder, it is volume equals pi times r times r times h. Well, we know that the radius is 3 inches and the height is 4. And we certainly know for pi, we're going to use 3.14. We have all we need to fill out the formula. So let's substitute. Volume equals 3.14, that's our pi, times a radius of 3 times 3 times 4 inches. Now, grab your calculator and pause the video. You should calculate or multiply your values in the formula. Whatever you get, it's going to be inches cubed. Pause the video right now. Let's check your work. You should have gotten 113.04 cubic inches of volume inside the mug. Now let's take a look at the problem at the bottom of the page. It states, find the volume of the concrete scuba pool. Well, if you look at this pool, it's a rectangular prism, but more specifically, it's a perfect cube. The length is 30, the width is 30, and the height is 30. So we'll be using the formula for the rectangular prism, length times width times height, step 1. Step 2, volume equals 30 times 30 times 30. Pause the video and multiply 30 times 30 times 30 and find the volume in cubic feet. You can check your work on the answer key at the end of this. Please place a smiley face after the word pool. When you're ready, you'll turn the page and go on to problem number 5 on the next page. But calculate the volume of this cube, so pause the video if you need to. In problem number 5, we have to identify faces, base faces, edges, and vertices of this solid. First of all, we can see the solid has a length of 5.4, please label that, a width of 4.8, and a height of 6. It's a rectangular prism. Although it looks like a cube, we certainly can't call it a cube because all the sides are different. So for letter A, the name of the solid, rectangular prism. If we're talking about letter B, the faces, we have the top and the bottom, the left side and the right side, the front and the back. So as you can see, we have 6 faces. As far as base faces go, please darken the bottom and the top. We have 2 base faces in this prism. When it comes to edges, we have 4 on top, 4 edges on the sides, and 4 edges on the bottom. 4 plus 4 plus 4 adds up to 12 edges. And lastly, vertices. Please make a dot along with me for every vertice. We have 1, 2, 3, 4 on top, and on the bottom we also have 4. So 4 plus 4 means we have 8 vertices. Let's move on to the next problem. In problem number 6, it states, find the volume of each. Use 3.14 for pi. We're given a cylinder, or information about a cylinder with no picture, and the same with the sphere. If you look at your formula sheet, you will see the volume formula for a cylinder is volume equals pi times r times r times h. We need to know the height, which we're given, but we also need to know the length of the radius. We're given the diameter is 6, but we need to cut that in half to get the radius. Please write this down. Our radius is 3. The same is true for the sphere. We're given a diameter, but if you look to your formula sheet, the formula for a sphere is 4 times pi times r times r times r, and that entire quantity is divided by 3. We need to know the radius length. So we're going to take the diameter of 10 and cut it in half. That means our radius is 5 centimeters. Take a moment and circle the radius for the cylinder and the radius for the sphere. Place a star right here to show that you're following along. Now, step 1, of course, is the formula, but now it's time to substitute. V equals 3.14 times a radius of 3 times a radius of 3 times a height of 8. In a moment, you will pause your video and multiply to get the volume of the cylinder in centimeters cubed. As far as the sphere goes, let's substitute. You're going to take 4 times pi, 3.14, times a radius of 5, times a radius of 5, times a radius of 5, and divide the entire thing by 3. In a moment, when you pause your video, you're also going to calculate the volume of the sphere. Now pause your video and use your calculator to figure out the volume of each. Right now, please. For the cylinder, you should have gotten 226.08 cubic centimeters. Give yourself a C. We're going to round the sphere to the nearest hundredths. It's approximately 523 point, and we round to 33 hundredths. So, which one has the greatest volume? Well, 200 compared to 500. Clearly, the sphere has the greater volume. How much greater? We're going to take the larger value, which is rounded, but nevertheless the larger value, and subtract the smaller value from it. Pick up your calculator and punch in. Pause the video if you need some time. 523.33 minus 226.08 and hit equals. There's a difference of 297.25. That is the difference between the two volumes. Make sure you show your work over here. Please place a square right above your work with an arrow pointing to your work. Let's move on to the next problem, problem number 7. You can pause if you need more time. In problem number 7, we are going to compare two swimming pools. Annie has a circular pool and Katie has a rectangular pool. Find the volume of each pool and compare. And remember, these pictures are not to scale, so don't make any decisions based on the look of the pictures. Let's take a look at Annie's pool. We can see that Annie's pool has a height of 4 feet and a radius of 11 feet. Please label that picture. It's a cylinder, so we'll be using the formula from the formula sheet for a cylinder. Volume equals pi times r times h. And remember, for this packet, pi is going to be the rounded version, 3.14. If we take a look at Kate's pool, we see that it's 20 feet long by 11 feet wide by 7 feet high. This is a rectangular prism, and we're going to use the formula volume equals length times width times height. Please take a moment and write down those two formulas. Now that we have both formulas written down, let's substitute the values into each formula. So, in this case, pi is 3.14 times a radius of 11 times a radius of 11 times a height of 4. You're going to calculate the volume of the first swimming pool in a moment. For the second swimming pool, which is a rectangular prism, you're going to take the length of 20 times the width of 11 times the depth of 7. Multiply the length, the width, and the height, and calculate the volume of the second pool. Pause your video now so you can complete the calculations. When you're ready, turn your video back on. Write your answer for each pool on the line and decide which pool holds more water and then subtract to find how much more water it holds. When you come to the end of the packet, you can grab the answer key and check your work for this page. Let's go on to the next problem. On this page, we are asked to find the volume of each sand bucket. As you look at our first bucket, it's a triangular prism. We're going to select the formula off of our formula sheet for the triangular prism. It is volume equals base times height divided by 2 times the overall height of the bucket. Remember, the information for the from the triangle, the 6 and the 16, are substituted here. 16 times 6 divided by 2, and then the overall height of the bucket is 30 inches. First, take care of the triangle formula and then multiply by 30. Come up with the answer in cubic inches for the triangular prism. For the next bucket, it is a rectangular prism, actually a cube. Length times width times height. And in this case, we know it's a perfect cube based on the dimensions. 12 times 12 times 12. Go ahead and find the volume of the cube. You're going to pause the video and answer the questions associated with this problem. Remember, it is not to scale when it comes to looking at the pictures. You have to make your decision based on numerical information. When you're ready, let's take a look at the problem at the bottom of the page. Go ahead and finish this problem, pause your video, and when you're ready, turn the video back on. At the bottom of this page, we are given a triangular prism. We are asked to find the faces, how many base faces, edges, and vertices. Well, if you take a look at the faces, we have a face on top, a face on the bottom, a face in the back, and another face on the back right, and of course the front face. There are 5 faces. We know the top and the bottom faces are called base faces. So there are 2 base faces. And edges. Grab your pencil and mark the edges with me. We have 3 edges on top, 3 edges on the side, and 3 edges on the bottom. 3 plus 3 plus 3 means there are 9 total. Now for vertices, we're going to use a dot. There are 3 vertices on top and 3 vertices on the bottom. 3 plus 3 means there are 6 total. Turn the page when you're ready, and let's complete the rest of the packet. This problem is from an old state exam. Let's read together. Tricia is choosing a container for her jewelry beads. The containers are shown below. Find the volume of the prism. Round your answer to the nearest whole number. So for the prism, we will use volume equals length times width times height. You need to show your work, and you need to round to the nearest whole unit. We're going to take a length of 23 times a width of 4.2 times a height of 8. 23 times 14.2 times 8. Grab our calculators, everyone, and punch it in. 23 times 14.2 times 8 and hit equals. Well, we get 261.28. But remember, we have to round to the nearest whole unit. What dot the heck tay? And we box to the nearest whole unit. The 2 is not 5 or more to raise that score. So the rounded answer is 261 cubic centimeters. Now let's find the volume of the cylinder. It states, find the volume of the cylinder. Round your answer to the nearest whole unit. Since they haven't told us what to do with pi, we're going to use the pi key. Volume equals pi times r times r times h. Well, we've been given a radius of 8 and an overall height of 23 centimeters. So let's multiply. Pi key times 8 times 8 times 23. Grab your calculator and punch in pi key times 8 times 8 times 23 and hit equals. Make sure you write down the entire value that appears on your screen. Remember, we're going to round it to the nearest whole number as well. We can go, what dot the heck tay? 4 is not 5 or more to raise the score. So the volume is 4,624. Now complete this problem by answering the questions below. Pause the video and answer the question. When you're ready, turn the video back on and let's move to the final problem. Our last problem is also off an old state exam. It states, a large tank of water in the shape of a right circular cylinder stands 25 meters high and 15 meters in diameter. So, we don't know our radius, but we do know that our diameter is 15 meters. In order to get the radius length, we're going to divide by 2. Grab your calculator and punch that in. 15 divided by 2 gives you 7.5 meters. Part A. What is the volume of the water in the tank? You may use 3.14 for pi. Well, we have a cylinder, so we're going to take V equals pi times r times h. And this time we'll use 3.14 times a radius of 7.5 times 7.5 times 25 meters in length. Go ahead and multiply and write the entire value down. We haven't been given any instructions to round, so do not round. Grab your calculator and punch in 3.14 times 7.5 times 7.5 times 25. You should get the following amount. Now continue this question on your own. It states, for every cubic meter, the tank holds 1,000 liters of water. What is the maximum number of liters of water the tank can hold? Well, we have a large amount of cubic meters. That's the volume. We're going to divide by 1,000 liters. We're going to see how many groups of 1,000 we can divide into our volume. Complete this problem on your own and then finish out this page. When you're ready, grab the answer key and check each page of your packet and return the answer key when you're done. This concludes the video on volume.